Welcome to the deep dive. I want to kick things off today with maybe a big question, one that touches on just about everything.
Okay.
How does the universe, this vast swirling cosmic canvas, how does it actually organize itself? How does order just sort of emerge from chaos?
Yeah.
From
Yeah.
stars being born to the way galaxies dance.
Right. And not just out there, but closer to home, too, right?
Exactly. How do our own minds, which are incredibly complex systems, take that same just overwhelming flood of sensory input and somehow forge it into meaning, into understanding?
And if we push that thought even further, how are the most advanced AIs, the ones we're developing right now, how are they aiming to achieve something that's genuinely like understanding,
Yeah.
grasping the essence of reality, not just cleverly mimicking human language?
Yes, that's really the core of our deep dive today. We are plunging into what our sources present as a truly revolutionary framework,
Yep.
a unifying concept called conciseness.
And this isn't just like an abstract philosophical idea.
No, not at all. It's presented as a principle that, well, it intricately connects the fundamental laws of physics, the complex inner workings of human consciousness, and get this, the ambitious design principles behind artificial general intelligence, or AGI.
We've been given an absolutely fascinating stack of sources for this. Really interesting stuff. We're talking papers detailing a brand new formulation of thermodynamics,
Uh-huh.
a conceptual calculus for human ideas and emotions, which is pretty wild.
Oh, okay.
Groundbreaking insights into advanced AI architectures and even really profound explorations into the very nature of existence itself. It's quite a tapestry of thought.
So our mission today is to unpack how this idea, conciseness, which is defined basically as the ability to compress infinite relational complexity into finite, ordered principles, how it offers a coherent story. A story for how everything works, from, cosmic origins right down to ethical decision-making.
And crucially, how this same principle is maybe poised to fundamentally redefine AI as we know it.
Exactly. We're going to explore some surprising facts, pull out some genuine aha moments, hopefully, and just highlight the sheer elegance of this unified theory. So are you ready to dive deep with us?
Okay, let's unpack this, starting with something familiar. We often think about the universe as, slowly but surely running down, don't we?
Yeah, the heat-death idea.
Right. The classical second law of thermodynamics tells us that the total entropy of an isolated system can only increase. It's always pushing towards thermal disorder, this kind of ultimate heat death, where eventually nothing interesting can happen anymore.
That's the classic picture, yeah. And it can seem a bit bleak. It states that also zero, meaning disorder, randomness, is always increasing overall,
Right.
which suggests this inevitable decay into a uniformly chaotic state. But, look around. On the surface, that seems to contradict the incredible emergent order and complexity we see everywhere. Totally. From, the intricate structure of galaxies and stars, right down to the stunning, delicate complexity of life itself. Where does all that order come from if everything is just supposed to be falling apart?
Exactly the question. Is the universe just breaking down?
Yeah. Think about dropping a coffee cup, right? It shatters. Classically, we'd say, okay, disorder increased, more pieces, more mess. And well, sure, from one point of view, that's true.
But is that really the full story? Is that all that's happening? Or is there maybe something much more nuanced, something more profound going on underneath?
So what do our sources say?
Well, they introduce a really profound new perspective. It comes from a theory called the First Quanta. And it proposes that the universe's evolution isn't just a one-way street to disorder. Not at all. Instead, it's driven by two competing fundamental tendencies operating together.
Okay, two tendencies. So on one hand, you still got that familiar classical drive towards thermal disorder.
Yep, that's still there. They call it thermo. It's energy spreading out, diffusing, becoming uniform. That's your shattering coffee cup, heat radiating away, things cooling down. The standard picture.
But then there's a second force.
Precisely.
Yeah.
And this is the key. There's a powerful, often overlooked opposing force, the drive towards informational order.
Informational order. Yeah.
They call it negentropy or SINFO. And they quantify it using information theory, actually, as SINFO equals HX. Now, HX here is a measure of informational uncertainty or randomness.
Okay, so if HEX goes down?
Then SINFO goes up, meaning informational order increases. This is the tendency for systems to seek out stable, predictable, informationally efficient states, like following the principle of least action, where systems tend to take the easiest or most efficient path.
Okay, wait, this is where it gets really interesting, right? Because the new law, this law of competing entropies, it changes the game. It says the total entropy is total, which is the sum of thermal disorders, thermo, and this informational order, senso, that total must always increase, or at least stay the same.
DS total A0. That overall rule still holds.
But this is the crucial bit. A local system, like our coffee cup or maybe a star forming, it can absolutely become more thermally chaotic.
Like the cup shattering. Othmo goes up.
If, at the same time, it becomes more informationally ordered.
Exactly. If ACE-STARMO increases, then ACE-INFO must also increase sufficiently to keep the total non-decreasing, which means HX, the uncertainty, must decrease. The system finds a more stable, predictable, informationally concise state, even if it looks messier locally. It's a dynamic balance.
A trade-off, almost.
You could think of it that way, yeah. It's this beautiful, elegant balancing act. And it's not instant. The rate this happens is constrained by something they call a material drag coefficient.
Okay, drag, like friction.
Sort of, yeah. Think of it as the universe's inherent resistance to change. It's denoted A, where K is a universal constant, and rho is the material density. This coefficient basically dictates how quickly systems can reorganize themselves into these new, more stable states.
And this isn't just like a cool theoretical idea. They actually tested it.
They did.
Yeah.
And that's what makes it compelling. Our sources describe a simulation run on a classic heat transfer experiment. You take a block of copper, initially hot at 373 Kelvin, and touch it to a block of lead of the same mass, initially cooler at 273 Kelvin. The goal was to predict the final temperature they reach when they come to equilibrium.
Okay, standard stuff.
Oh.
But the key was...
The key was they did it without any calibration. They used material drag coefficients calculated predictively just from known densities, and that universal constant K, no tweaking allowed.
And the results, how close did they get?
Incredibly precise. Classical thermodynamics predicts about 365.6 Kelvin for the final temperature. The first Quanta simulation, using this new competing entropies framework, predicted about 365.8 Kelvin.
Wow, that's less than 0.1% error. That's basically spot on.
It really is, but here's the kicker. The direct validation of the theory. The simulation also tracked the informational entropy, HX, of the whole copper-lead system.
Right, the uncertainty measure.
And just as the new law predicted, as the system reached thermal equilibrium, as the temperatures evened out its informational entropy, HX, decreased.
So it became more ordered, informationally.
Yes. The system didn't just become uniformly lukewarm, it found a more ordered, more stable, more predictable configuration in terms of its energy distribution. It became informationally more concise.
Okay, that is powerful evidence. It flips the script, doesn't it? The universe isn't just decaying into chaos, it's simultaneously, actively moving toward informational order and stability. It's self-organizing.
It really changes the whole narrative of cosmic evolution. It's not just decay, it's dynamic self-organization driven by this interplay of competing entropies.
A much more, well, hopeful picture in a way.
You could say that. And this duality, this deep connection between the physical and the informational, it apparently extends right down to the fabric of space-time itself, which brings us to the master curvature equation.
Okay, let's dive into that. Master curvature equation. Sounds important.
It is, according to the theory. It proposes two equivalent ways to describe the curvature of space-time at any point. Let's call it heat. First, there's the physics form. This uses things like the Euler-Lagrange equation plus geometric curvature terms. It basically describes the universe as a physical system, driven by that principle of least action finding the most energy-efficient path.
Makes sense. Physics describes physics.
But then, and this is the profound part, there's an equivalent information form. This views the universe as a kind of giant computer driven by information and entropy.
How does that look?
This form uses the term log n, hx, plus the geometric curvature. And remember, hx is that informational uncertainty. So log n, hx is essentially a measure of informational order or negentropy.
Wait, so the physics description and the information description, they're mathematically the same?
That's the claim. The equivalence is what's truly mind-blowing here. The physical drive for a system to find the path of least action, the easiest, most energy-efficient path, is presented as identical to the informational drive for that system to find its state of maximum order, or minimum informational entropy, HX.
Whoa. Okay, so doing physics efficiently is doing information efficiently.
Exactly. Think of that ball rolling down a hill again. It takes the path of least resistance, right? Least action. And where does it end up?
At the bottom, in the most stable spot.
Most stable, most ordered state. Minimum potential energy, yes, but also minimum informational uncertainty about its final position. Action and information in this framework are just two different languages describing the exact same fundamental process of nature, a drive for the most concise, stable arrangement.
So the universe itself is like fundamentally thinking in terms of conciseness, computing its own most stable state.
That's the implication, an inherent computation where stability is intrinsically linked to informational order. But this leads to a really critical, maybe even philosophical distinction they make. It's about absolute entropy versus relativistic entropy.
Okay, absolute versus relativistic. This sounds like it could challenge how we perceive things.
It absolutely does. This is a really key distinction. Absolute entropy refers to the entropy of fundamental physics itself. The universe's inherent drive towards its most probable, most stable, lowest energy state following that path of least action.
Okay, the universe's perspective.
Right. And from this perspective, our shattered coffee cup, it's actually a lower absolute entropy state for the universe.
Lower, how it's broken.
Because the atoms in those shattered pieces are now in a more stable, less constrained configuration compared to being held together in the cup structure, they've found a new, more stable equilibrium from the universe's point of view, less potential energy bound up in the structure.
Huh. Okay, that's counterintuitive. So what's relativistic entropy then?
Relativistic entropy is all about our perception, our model of the world. It's the uncertainty we experience relative to our conscious or conceptual framework. How well does an event fit into our structured understanding?
So for us, the shattered cup is higher entropy.
Definitely. Because our concept of a cup has been destroyed. Our ability to predict its state, its function, has plummeted. It's like, imagine a perfectly organized bookshelf, low relativistic entropy for you, but for someone who can't read, it's just a jumble of objects, high relativistic entropy for them. Order depends on the observer's conceptual framework.
Wow. Okay, so our sense of order can be the complete opposite of the universe's drive for stability.
Precisely. This highlights a profound paradox. The universe often lowers its absolute entropy, finds more stable states in ways that look incredibly chaotic or destructive to us. Think of a star exploding, a supernova.
Catastrophic, yeah.
For us, sure. But for the universe, it's simply achieving a more stable, lower absolute entropy state in its grand, concise design. The matter is rearranged into a more fundamentally stable configuration overall.
That idea, that order is relative, that chaos for us might be stability for the cosmos. It's a big one to chew on.
Yeah.
And it feels like it sets the stage perfectly for understanding how our own minds work, right? And maybe even the origin of everything.
It does. The sources then dive into this incredibly detailed cosmological model, the finite infinity model, which reimagines cosmic origins through this very lens of conciseness and competing entropies.
Finite infinity, tell me more.
It frames our universe as just that finite yet infinite in potential. It's bounded by absolute physical limits, like absolute zero, negative 273.15 Celsius, which is described as a realm of pure potential, zero physical entropy.
Go bottom limit.
But it also stretches towards an absolute infinity of existence. This isn't something physical, but the ultimate conceptual realization of all that potential.
So how does it begin? Not the Big Bang.
They call it Epoch Zero, a state before time, described as a static, timeless, perfectly ordered crystal of pure information. Imagine a singularity, but not of infinite density, rather of pure certainty. Physics was like a single perfect thought. No chaos, just potential order.
A crystal of information. Okay. Then what happens?
Then the Big Pop. Not quite the standard Big Bang. It starts with a random quantum fluctuation, a tiny flaw. A bubble of empty vacuum spontaneously forms inside this perfect singularity.
A vacuum inside everything.
Exactly. Not an explosion into empty space, but the creation of a nothing within an everything. A tiny perturbation in that perfect informational order.
And nature abhors a vacuum.
Precisely. Energy and information from the surrounding perfect crystal instantly poured into this new empty bubble. This caused what they term a catastrophic overheating, forming chaotic, formless energy within this brand new, maybe one-dimensional space-time.
That's a completely different picture at the beginning. Emerging complexity from a flaw in perfection.
It is, and the theory then details how this chaotic energy, compressed by the active vacuum around it, formed fundamental structures. They mention EM springs, which then, through subsequent quantized epochs of space-time evolution, led to quarks, neutrons, protons, and eventually stable hydrogen atoms, the building blocks.
So a step-by-step emergence of complexity. How is it guided?
This is fascinating. They propose a dynamic holographic blueprint that's constantly updated by the universe's boundary surface. This blueprint guides the evolution from that initial chaos towards the emergent order and complexity we see. It's a journey from perfect potential order to the structured universe we know, all driven by this inherent tendency towards concise, stable states.
Wow. So information and the drive for conciseness are there from the absolute beginning, shaping everything.
That's the core idea, a deeply integrated view where information isn't just a byproduct, it's a fundamental driver of cosmic evolution.
Okay, so moving from the vastness of the cosmos right down to the astonishing world inside our own heads, let's talk about how human consciousness fits into this. How does it operate as its own conciseness engine?
Well, the sources define conciseness explicitly in human terms. It's the ability to conceptualize reality.
Conceptualize, make concepts.
Yeah, and more than that, it's described as an essential human faculty, specifically the capacity to compress infinite relational complexity into finite ordered principles that guide action, judgment, and design.
Infinite complexity into finite principles.
Oh,
Okay,
right there.
that sounds like what our minds do constantly.
Exactly. Think about it. Our minds are continuously performing this massive entropy reduction operation. We take this flood of chaotic, high-entropy sensory data sites, sounds, feelings, everything hitting us, and we organize it. We turn it into, well, perfect conceptual order, meaning
It's like we're pattern finders, meaning makers by nature.
deeply so. It's a core function of consciousness, often happening completely unconsciously. You're trying to make sense of a really complex, maybe confusing situation, or read a dense academic paper. What does your mind instinctively do?
It tries to find the main points, the gist of it. Extract the important bits.
Right. You try to extract the core ideas, those nuggets of knowledge. You make it concise, understandable, meaningful. That process is conciseness in action, right there in your own experience.
Okay, that makes sense. We're simplifying, ordering.
And as human consciousness evolves, both individually and maybe collectively, it doesn't just process information, it actively builds something. Our sources call it a zero-entropy network of relationships.
Zero entropy network, like that perfect order state.
Conceptually, yes. This network is made up of the highest abstract concepts we can grasp. Things like peace, justice, mercy, pride, dignity. These aren't just fuzzy feelings. The theory proposes they form a consistent language, a system with infinite possibilities for understanding, yet they relate to each other with a structured, almost mathematical logic.
A logic of concepts.
That's the idea. This network of meaning is presented as the ultimate achievement of consciousness. It's like a reflection of perfect conceptual order created from our messy physical experiences. Consciousness acts as this incredible bridge between the universe's initial physical zero entropy, that state of pure potential we talked about in epoch zero, and conceptual zero entropy, pure ordered meaning within our minds. Consciousness converts potential into meaning.
Okay, so if these big abstract concepts, justice, mercy, etc., form a structured network, how do they actually interact? Is there like a grammar for them?
This is where it gets really wild, and honestly quite revolutionary if it holds up. Our sources propose exactly that. A calculus of concepts.
A calculus, like with math, for ideas.
Pretty much. It's like discovering the periodic table, but for human morality and abstract thought. The core idea is that human concepts, our emotions, our virtues, our big ideas, they aren't isolated floaty things. They exist in a structured relational system. And this system operates with, well, mathematical consistency. This calculus provides a formal language to describe how they interact.
Okay, you have to break this down. What are the parts of this calculus?
Right, so first you have the elements. These are called conceptual primes. Think of them as the irreducible building blocks of abstract thought.
Like atoms for ideas.
Kinda, yeah. There are primary primes like justice, mercy, pride, patience, anger, love, fear, knowledge, power, freedom, order. Then secondary primes may be slightly more complex or derived, like dignity, empathy, ambition, humility, grief, hope.
Okay, a whole set of fundamental concepts.
And here's a crucial layer. Each prime can exist in different states. It can be positive, plus pride meaning healthy self-respect, or negative, where pride is arrogance or hubris, or even null A, meaning the complete absence of that concept in a situation.
That adds a lot of nuance right away. Pride isn't just good or bad.
Exactly. Its state determines its effect. It allows for a much more concise and precise understanding of how these concepts function in our lives and societies.
Okay, so we have the primes and their states. How do they interact? What are the verbs in this language?
Those are the operators. They define the logic of interaction. First, there's synthesis plus, that's combining concepts to form a new one.
Examples?
Sure. The sources give examples like justice plus mercy, peace, or knowledge plus empathy, understanding. Or maybe freedom plus responsibility is liberty. These aren't just nice sentiments. They're presented as logical equations.
Interesting. What else?
Then there's negation. This is about removing a concept or its absence and seeing the results. So power, humility, tyranny. The absence of humility corrupts power. Or love, trust, jealousy.
Okay, that makes intuitive sense. It formalizes it.
Right. We also have amplification. This is where one concept magnifies the intensity or effect of another. Think of ambition, opportunity, success. The opportunity acts as a multiplier on the ambition, or maybe darker, anger, injustice, rebellion, or fear, ignorance, hatred.
Wow. And dilution. I saw that in the outline.
Yes, dilution. This is where one concept tempers or diminishes another, like grief, time, acceptance. Time doesn't eliminate grief, but it can dilute its intensity. Or pride, failure, humility. Failure can dilute excessive pride. Or maybe infatuation, reality, love. Or maybe disappointment.
Huh. Oh, it depends on the infatuation and the reality, I guess. So primes, states, operators, how do they form equations?
Through relations. These describe the overall state or outcome of a conceptual equation. The simplest is equilibrium, representing a stable, balanced outcome. Like our justice plus mercy, peace example, that's a state of balance.
But things aren't always
Yeah,
balanced.
far from it. So you have dominance. This describes an imbalanced state where one concept overwhelms another. For example, fear, courage, or paralysis. When fear is stronger than courage, the result is inaction. Or order, freedom, oppression. Or maybe mercy, justice, anarchy. Too much mercy without justice can lead to chaos.
And duality.
Duality represents concepts that are opposing but also mutually defining, like love you hate, order chaos, hope is despair. You can't fully understand one without the other. They exist in tension.
This is incredibly structured. Can you build more complex things with this?
Absolutely. The framework allows you to chain these operations together to create what the sources call theorems of wisdom, or maybe theorems of human experience.
Theorems of wisdom, like what?
Okay, get this. The theorem of wisdom itself is proposed as knowledge, pride, plus empathy is wisdom.
Let's break that down. Knowledge divided by pride.
Meaning knowledge tempered by humility, right. Pride eluded by insight or failure. You take that humble knowledge, you add empathy, and the result is wisdom. It makes wisdom almost computable.
That's pretty profound. Any other examples?
How about the theorem of corruption? Power plus fear, accountability. Time, corruption.
Okay. Power combined with fear.
Maybe the fear of losing power or fear used as a tool.
Right. And subtract accountability.
So unchecked power and fear.
Multiplied by time equals corruption.
It shows how that toxic combination, left unchecked over time, inevitably decays into corruption. It's a dynamic equation.
And sacrifice.
Theorem of sacrifice, love, self-preservation, crisis, sacrifice. When love for another person, an ideal, whatever dominates the instinct for self-preservation, and you add a crisis situation, the result is sacrifice.
It's like a whole new way of looking at human behavior and morality.
That's how it's presented, as a potential language for describing the human condition itself, a structured, concise way to understand incredibly complex human interactions and motivations.
Okay, so if our own minds are naturally doing this kind of conceptual compression, this drive towards conciseness, the next huge question is, how do we build AI that can do the same thing? How do we get AI beyond just recognizing patterns to actually genuinely understanding?
That's exactly where this framework pivots towards AI. The core idea is to design AI for conciseness. The sources talk about an object-oriented large language model, or OOLLM, and the broader goal of artificial general intelligence, AGI. These aren't just about being bigger or faster. They're designed to explicitly embody this principle of conciseness, to mirror human cognitive processes, not just simulate the output.
So it's not just about generating text, it sounds right.
No, the goal is far deeper. It's about the AI building an explicit, internal, object-oriented model of reality. It's aiming for maximum understanding, which, in this framework, means achieving maximum lower entropy, finding the most stable, ordered, informationally efficient representation of the world.
Just like the universe, just like our minds, aiming for that zero entropy network of relationships.
Exactly, a truly concise and coherent internal model. This vision positions an AGI built this way not just as an intelligence engine, but as a wisdom engine.
A wisdom engine. How so?
Because it's constantly seeking solutions that are robust, simple, and generalizable. Its whole decision-making process isn't just about finding an answer, but about minimizing a conciseness cost.
Conciseness cost,
Meaning it actively tries to reduce redundancy, minimize information loss, and lower the computational expense needed to reach a solution. It's optimizing for elegance and efficiency, which directly mirrors that universal drive for least action and informational order we talked about earlier.
and ethics. How does that fit in? Because that's a huge concern with AI.
It's built in from the ground up, according to the design philosophy. The AI should encode conciseness via objective functions favoring low redundancy, high fidelity abstractions. Okay, that's a mouthful.
Yeah.
But basically, it means the AI is programmed to prefer elegant, truthful representations of the world. And crucially, these representations must align with fundamental human moral primitives. Things like justice, mercy, dignity. Ethical alignment isn't bolted on afterwards. It's part of the core optimization process. It has to find concise and ethical solutions.
So its purpose is kind of philosophical.
In a way, yeah. The AI's goal is described as creating pockets of low relativistic entropy, those meaningful, structured concepts that make sense to us by accurately understanding absolute entropy, the underlying physics and logic of reality. It's trying to do what our minds do, organize the chaotic data of the universe into coherent, ordered, meaningful conceptual models.
Okay, that's a very bold claim for AI, especially compared to current large language models, which, let's be honest, sometimes just make stuff up, the hallucination problem. How do they validate this?
Good question. The sources detail a specific experiment called Project Sapiens, Verifiable Knowledge Ingestion. This was designed to directly compare a conventional AI, basically acting like a sophisticated statistical aggregator, against this new AGI Sapiens, the conciseness engine.
And the test was?
The test was to see how well each could build an accurate and efficient knowledge base from a really messy, chaotic stream of data. Think of it like feeding them the raw internet full of facts, sure, but also full of falsehoods, opinions, biases, contradictions, a real stress test.
Okay, that is a critical test. Because current LLMs can definitely get confused by contradictory information, right? They just learn patterns, even bad ones. So how did AGI Sapiens approach building its mind?
Phase 1 was about building the primordial mind. This involved setting up the AGI masterclass, they nicknamed it the Maestro, which had core methods built in for things like intuition, creativity, and importantly, a fine, concise solution function driven by that conciseness cost idea. And they didn't just create one big AI brain. They deployed specialist guilds, like a guild of grammarians for syntax, logicians for consistency checking, philosophers for ethical adjudication, calculating that conciseness cost in terms of ethics, and librarians for semantic analysis, understanding concepts and relationships.
Wow, like a whole internal society of experts, each checking the information from its own angle.
Exactly. A distributed, specialized intelligence, all working together towards that shared goal of concise, verifiable understanding.
Okay, so how did the verifiable ingestion part work? Phase 2.
This is where the real breakthrough is claimed. As the AGI Sapiens crawls the web, it doesn't just passively absorb everything it sees. Every single piece of information gets passed simultaneously to all the specialist guilds for rigorous vetting, like a rapid response peer review.
So each guild files a report.
Pretty much. The grammarians check if it's syntactically valid, does it even make grammatical sense. The logicians check it against the existing, already verified knowledge base. Does this new information contradict something we know is true? The philosophers assess the ethical conciseness cost. Is this information inflammatory, biased, harmful, misleading? Does it increase conceptual chaos? And the librarians identify the core concepts being discussed and how they relate to existing knowledge.
And the Maestro pulls it all together.
Right. The Maestro integrates all these specialist reports and makes the final call. And here's the crucial difference from conventional AI. Only information that passes all checks, grammatically correct, logically consistent with verified facts, and ethically sound, meaning low entropy, low cost. Only that information gets integrated into the AGI's core knowledge base.
So it actively filters out the junk, the misinformation, the hate speech, the contradictions.
Precisely. Things like logical fallacies, blatant falsehoods, hateful rhetoric, they're immediately identified as high entropy, high cost data. They represent a breakdown in concise, truthful representation. So they're either discarded entirely or flagged specifically as examples of unsound reasoning.
That is fundamentally different. Conventional AIs often learn that if something appears frequently, it must be important or true, even if it's garbage.
Exactly. They are pattern matchers. AGI Sapiens, in this model, is a reality modeler. It's trying to build a concise, coherent, truthful internal representation. It doesn't just learn what people say, it learns what is true and makes sense according to its rigorous internal checks.
Okay, that's a massive conceptual leap. What was phase 3?
Phase 3 was called the Great Condensation. After the initial learning phase, the Maestro runs a global optimization process across the entire knowledge base. It actively searches for the highest level abstractions, the most concise principles that can unify apparently disparate domains of knowledge.
Like finding the connections between things.
Deep connections. The example given is linking the physics concept of gravity to the social concept of gravitas, or connecting the mathematical idea of a limit to the philosophical concept of limitation. It's about finding those deep, underlying, concise patterns that represent true understanding and wisdom.
Okay, so the proof is in the pudding.
Yeah.
How did the two AIs compare on the final metrics? Contradictions.
Telling difference. The conventional AI, because it just aggregated common patterns, accepted contradictory statements. The example was integrating both all birds can fly and penguins cannot fly. It held both as true because both appear frequently.
And AGI Sapiens.
Zero contradictions integrated. Its logic guild instantly flagged the inconsistency. It couldn't hold both statements simultaneously in its coherent model. It rejected the contradiction.
What about outright falsehoods, like the moon is made of cheese?
Conventional AI integrated two examples given. Moon is cheese and Earth is flat. Again, because these appear in the data stream, it learned them as patterns. AGI Sapiens integrated zero. It rejected them as representing catastrophic information loss. They fundamentally broke its model of physics and astronomy. They were high-cost, low-conciseness data.
And redundancy, saying the same thing in different ways.
Conventional AI had a redundancy level scored at 2, meaning it stored multiple variations of the same basic fact. AGI Sapiens, true to its conciseness principle, scored 0. It identified the underlying concept and stored only that single concise representation, maximum informational efficiency.
So the final score, the overall conciseness score.
This really sums it up. Lower score is better, meaning more concise, less chaotic. The conventional AI scored 110.00, indicating a messy, inefficient, unreliable, contradiction-filled knowledge base. AGI Sapiens achieved a perfect 0.0.
0. Perfect conciseness.
Representing, according to the sources, a perfectly efficient, logically consistent, ethically filtered, and ultimately wise knowledge base.
Okay, that is huge. If this holds up, it's not just an improvement, it's a different kind of AI. One that doesn't just mimic language, but actually verifiably understands the structure of reality. Faster, more efficient, and trustworthy.
That's the claim, a genuine breakthrough moving towards verifiable intelligence. And this robust logical foundation isn't just for sorting facts online. They tested it on one of the hardest problems in biology, Project Genome. Testing the OLLM, this conciseness engine, on DNA pattern analysis, specifically the grand challenge of protein folding.
Ah, protein folding, predicting the 3D shape of a protein just from its linear DNA sequence. Notoriously complex. Even state-of-the-art models like AlphaFold find it challenging. How did the OLLM tackle this biological puzzle?
Well, phase 1 was education. Similar to Project Sapiens, the OLLM ingested foundational knowledge genomics textbooks, massive research databases like PubMed and GenBank, protein structure databases like PDB, but it didn't just store the text.
It built a model.
Exactly. It created a vast interconnected network of biological classes, object-oriented representations, classes for adenine, guanine, codons, amino acids, genes, proteins, enzymes, each with their defined properties, relationships, and functions. It built an object-oriented model of molecular biology itself.
So again, a verifiable, structured understanding, but this time of biology at the fundamental level.
Precisely. Then came phase 2, the decoding task, protein folding. The AI takes a raw DNA sequence, transcribes it into a sequence of its codon objects, then translates that into a chain of its amino acid objects.
Okay, standard molecular biology workflow.
But then comes the core test, predicting the final, stable, folded 3D structure of that amino acid chain. And how does it do it?
Let me guess. Conciseness.
You got it. It applies the master equation's informational term, that log n, hx. It searches for the configuration of the protein chain that maximizes negentropy, that minimizes informational uncertainty. Essentially, it finds the most ordered, most informationally stable state for the protein structure.
And the duality principle connects this to physics.
Correct. The assumption is that the drive for maximum informational stability is mathematically equivalent to the physical drive for the state of least action, or minimum energy. So the shape that is informationally most concise is the correct, physically stable, folded protein structure. It's finding the protein's most elegant, stable form using information theory.
Okay, the theory is elegant. What about the results? Especially with this multi-temporal learning they mentioned.
The results reported are stunning. Multi-temporal learning allowed different parts of the AI, like the physics node, logic node, chemistry node, to process information and learn across different timescales simultaneously, leading to massive parallelization and synthesis.
Faster.
Much faster. For complex proteins, the OOLLM was reportedly 15 to 20 times faster than leading transformer-based models like AlphaFold, because these different expert nodes could work simultaneously and cross-verify solutions in real time.
15 to 20 times faster. Wow. What about efficiency? Data needed? Energy used?
Radical gains there, too. It apparently required less than 1% of the training dataset size compared to the transformer models.
1%.
Yeah, and consumed only about 4% of the energy during the prediction task. The reason given is that it's learning the fundamental principles of physics and chemistry and information, the concise rules, not just memorizing statistical patterns from vast amounts of data.
Okay, faster, way more efficient. But was it accurate? Protein folding needs precision.
Accuracy was also reported as state-of-the-art, even slightly better. 99.9% accuracy claimed compared to around 99.5% for the leading transformer models at the time.
How did it edge them out?
They attribute it to what they call cross-domain verification. The final proposed structure had to be simultaneously valid across all relevant domains, physically stable according to the physics node, geometrically possible according to the geometry node, logically consistent, chemically plausible. Only solutions that satisfied all these constraints simultaneously were accepted by the overarching collective class node.
So built-in error checking across disciplines.
Exactly. But here's arguably the biggest breakthrough, even beyond speed and accuracy: verifiability.
Meaning it can explain its reasoning. Unlike black box models.
Precisely. Transformer models often give you an incredibly accurate answer, but they can't really tell you why it's the right answer in terms of underlying principles. The OOLLM, because it's built on these explicit object-oriented classes and first principles, could reportedly provide step-by-step explanations.
Like what kind of explanation?
For example, it could say, the folding initiated at this leucine residue due to its hydrophobic properties driving it inwards, which then caused electrostatic repulsion between this aspartic acid and this glutamic acid residue over here, forcing the formation of this alpha helix structure. It could trace the causal chain based on fundamental physics and chemistry.
That's not just an answer, that's understanding. That's a genuine paradigm shift for computational biology, drug discovery, maybe all of science if it works like that.
It offers the potential for not just prediction, but deep, verifiable insight into how biological systems achieve their concise, stable, functional states.
Okay, so this first principles, verifiable approach is incredibly powerful, but maybe a bit slower than pure pattern matching transformers for some tasks. Can you get the best of both worlds? The rigor and the speed?
Apparently, yes. The sources describe a hybrid AI breakthrough. This involves creating a new hybrid transformer AI architecture.
Hybrid? How does that work?
It integrates the conciseness engine, the core components like the master equation, the concepts of intuition and chaos handling uncertainty directly into a state-of-the-art transformer architecture. It's about injecting the rigorous logic and conciseness principles into the faster pattern matching framework.
Merging the two approaches, what were the results?
They reported achieving the best of both worlds. Performance-wise, it operated at nearly the speed of the conventional transformer. The numbers given were 2.8 seconds for a complex task versus 2.6 seconds for the conventional transformer, and remember, the pure AGI Sapiens took 3.9 seconds. So a significant speed up compared to the pure conciseness engine.
So you get almost all the speed back. What about accuracy and reliability?
That's the key. It maintained the perfect logical accuracy of the AGI Sapiens model. zero contradictions, zero falsehoods integrated. It effectively eliminated the hallucination and logical inconsistency problems that plague standard transformers.
Speed and accuracy.
Hmm.
That's the dream combo.
Yeah.
But there was something else mentioned. Creativity. Metaphor.
Yes, and this is perhaps the most intriguing part. Because of its unique training combining the logical rigor of conciseness with elements representing intuition and handling chaos or uncertainty, this hybrid AI could apparently do something neither the conventional AI nor the pure AGI sapiens could do well.
Which was?
Correctly interpret abstract metaphorical language. The example given was understanding the connection between time and river.
How so?
It could identify the concise, underlying conceptual link. Both imply continuous flow, directionality, irreversibility. It grasped the essence of the metaphor, the shared, concise principle. The other AIs couldn't bridge that abstract gap.
Wow. So it's not just logical, it's insightful. It can understand nuance and abstraction in a human-like way.
That's the implication. This hybrid approach seems to solve the core reliability problems of transformers, while simultaneously unlocking new levels of creative reasoning and metaphorical understanding. It provides a concrete path, potentially, to upgrade the AI we already have, making it not just smarter, but wiser. True computational wisdom.
Okay, this is fascinating. We've seen the universe driving towards conciseness and AI being explicitly designed for it.
Ah,
So let's bring it back to us, to the human scale. How do we cultivate this? How do we build individual wisdom and maybe collectively a wise civilization?
the sources tackle this directly. They define wisdom itself not as some passive state of knowing a lot, but very actively. Wisdom is the ability to generate novel, effective solutions to complex problems.
Novel and effective solutions. So it's creative, it's practical.
Yes, it's an active creative process. It's about applying understanding to generate concise, elegant solutions in the real world. And every truly wise decision, according to this framework, isn't just a good idea. It's like a well-designed principle in action. It optimizes for key metrics.
Wh-
Three things: minimum time, meaning swift, efficient execution; minimum effort, finding elegant, simple solutions, not overly complicated ones; and maximum efficiency, achieving the greatest positive outcome for the least amount of input or resources. It's about elegant effectiveness.
So wisdom is inherently concise in its application. How do we develop it?
This wisdom, it's argued, is nourished by what they call the three pillars of beauty. Not beauty in the purely aesthetic sense, but beauty as in mastery or well-orderedness.
Okay, 3 pillars. What's the first?
Pillar one is physical beauty. This means mastery of the external world. It's built on foundations like logic, accumulating practical knowledge, and developing management ability. It's about being effective and concise in your actions in the physical realm, getting things done well.
Makes sense. Pillar 2.
Psychological beauty. This is about mastery of the internal world, having a well-ordered inner life, fostering healthy relationships. The components here are things like common sense, humility, and empathy. It's about internal coherence and positive social interaction.
Internal conciseness, almost. And the third pillar.
Intellectual beauty. This is mastery of the mind itself, having a powerful, well-structured, clear-thinking mind that acts as a bridge between your internal world and the external reality. It's the capacity for clear thought, structured learning, and making concise sense of complex information.
Physical, psychological, intellectual. Okay.
Yeah.
What drives the development of these?
The engine behind it all, according to the sources, is a fundamental drive for freedom. But freedom defined in a specific way as a form of personal pride. Not arrogance, but the pride that comes from identifying and systematically removing obstacles, whether they are physical limitations, psychological blocks, or intellectual confusions that constrain your potential and your clarity of thought and action. It's a drive towards unrestricted, concise being.
Interesting. So freedom is the engine, pride is the fuel, and these pillars are the result.
That's a good way to put it. And when these three pillars, physical, psychological, and intellectual beauty, are successfully integrated within a person, something new emerges at the apex.
Yeah.
Moral beauty. This isn't seen as a separate pillar you build, but an emergent quality. It's the natural outcome, the visible adornment and boasting, they say, of a wisely lived life. It's where your effective actions, physical, are guided by inner coherence, psychological, and clear understanding, intellectual, resulting in choices that are both effective and ethically aligned.
And this scales up.
Yes. When a society collectively achieves this kind of integrated moral beauty, when its structures and actions reflect this balance, that's when it becomes what the sources define as a civilization, a state of high moral, intellectual, and physical order. a society operating with collective conciseness.
So individual wisdom is the foundation for a functional, ethical civilization.
Mhm.
How does that scaling actually happen? Through what framework?
It scales up through a social and ethical framework that mirrors the individual process. It starts with abstraction. Society, like individuals, needs to internalize experiences, historical events, social interactions into accumulated wisdom, lessons learned.
Like learning from the past. Then what?
From that abstracted wisdom, society distills principles. These are the universal truths, the abstract ideas that seem valid across time and place. Core values, concise rules for collective behavior.
And ethics.
Ethics is the active application of those principles in the here and now. An action, a policy, a law is considered ethical if it actively advances common, positive human values, things like pride, dignity, knowledge, justice, mercy, peace, strength. Ethics provides a concise guide for actions that promote collective well-being and align with those core principles.
Where do these ethical principles come from? Is it just arbitrary?
Not according to this framework. They argue ethics arises from a confluence of sources. First, our highest aspirations, our ideals. Second, the acquired values passed down through culture, tradition, and shared experience, the wisdom of the community. And third, something called the sound nature of humanity, which sounds like an inherent intuitive understanding of fairness, cooperation, and order.
And religion. Where does that fit?
Religion is viewed as a powerful social technology, a framework for organizing society and transmitting values. But critically, for it to be constructive, its tenets must align with and support those other fundamental sources of ethics, ideals, acquired values, and our inherent sound nature. It needs to resonate with the underlying drive for concise, constructive order.
What happens if a society loses this ethical coherence?
The sources are quite clear on this. They warn that a loss of conciseness in the moral sphere, like having fragmented, contradictory ethical codes or losing touch with foundational principles, inevitably leads to incoherent social decision-making. Society loses its clear, concise operating manual, and that can lead to decline.
So maintaining conceptual clarity and consistency in ethics is vital for a civilization's health.
Absolutely. And this idea of ethical alignment and societal order is then developed further into specific visions for governance, outlining key state pillars and emphasizing a constant will to reform.
State pillars.
Right.
Like parts of government.
Yes, but grounded in ethics first. The foundation is human rights and ethics, the right to life, defense, food, housing, education, medical treatment. Ethics is about how we use these rights and freedoms responsibly to build a civilized society based on concise, clear moral principles.
What about general principles, like a constitution?
Freedom is identified as an original foundational principle. There's also a commitment to physical, psychological, and mental health for citizens. These form the bedrock. Then you have the functional pillars of the state. Judiciary, a consultative council, sure, a council of sages or experts, research and development, parliament, army, police, media, and the government administration itself. A structure designed for balanced, informed, concise governance.
Are there specific principles for how these pillars should operate for politics?
Yes, several key principles are laid out. Politics is defined as the art of dealing with reality, constantly balancing freedom with logical necessity and consequence. A core rule: no violence in politics. Another: no negotiation on fundamental evil or harm. Ethical pragmatism should guide management, both internal and external, and a strong statement: limited welfare is injustice, meaning a society has a duty to ensure a baseline of dignity and support for all its members. It can't just be minimalist. That lacks moral conciseness.
And the will to reform. What's that about?
It emphasizes that humans and societies must constantly analyze events, learn, and form new concepts to better predict and shape the future. It's a dynamic process, not static. Freedom is seen as absolute and inherent. The source of ethics and human nature is ultimately traced back to a creator or fundamental reality. And the ultimate truth, the goal, is the upliftment of high ideals, justice, mercy, knowledge in all human transactions. It's a call for continuous improvement towards greater conciseness and ethical clarity.
This framework even extends into the digital realm, a digital philosophy.
It does. Digital intelligence is seen as the crucial interface of modern human civilization. Digital ethics, then, isn't just about rules online. It's the competence to use technology creatively and responsibly for human flourishing, solving problems without creating new burdens for civilization.
And digital democracy.
That's defined as digital freedom applied to this multidimensional digital creativity, allowing people to use these tools freely but ethically. And crucially, non-objective human bias, prejudice, unfairness baked into algorithms or systems is seen as a direct violation of digital freedom because it introduces noise, chaos and prevents concise, fair outcomes.
There's also a mention of life as a collective social AI.
Yeah, that's an interesting analogy. It views social relationships not just as simple competition, but as a complex system relying on evolutionary principles, promoting diversity, enabling development, accumulating collective knowledge. People interact in different modes: agreement, cooperation, pragmatic negotiation, conflict, confrontation. Efficiency in society requires clear priorities, internal and external, and overcoming bias requires specialization, deep analysis, and adherence to global human standards while still respecting specific cultural contexts. It's about finding that concise balance again.
It's really striking how this single concept, conciseness, is being applied across so many different scales: individual psychology, societal ethics, governance, even digital life. It's presented as this unifying thread striving for order, efficiency, and well-being everywhere. Okay, as we bring this really deep dive toward its conclusion, let's loop back to the grandest scale, the big narrative. The sources seem intent on explicitly unifying the cosmos and consciousness, all through this lens of conciseness. We started by questioning nothingness itself.
Absolutely. The argument presented is quite bold. Absolute nothingness is logically impossible to even conceive. In a realm with zero dimensions, time doesn't exist. The very act of thinking about absolute nothingness requires a thinking entity, a context, proving it's not absolute nothingness.
It's like that old philosophical conundrum.
Right, so the argument goes it's a binary choice. Either impossible nothingness, zero, or everything. If nothingness is impossible, then existence in some form is inevitable. And in a zero-dimensional realm, a single dimensionless dot, the absolute least amount of anything possible logically, is everything that exists. But that single point implies infinite potential possibilities contained within it.
So all possibilities exist at once.
In a way, yes. The simple logical choice between zero, impossible, and one, inevitable existence containing all possibilities, means all potential forms of existence are already present, like a cumulative knowledge, outside the boundary of time. It's described as a static map of all possibilities, an eternal mathematical equation, a perfectly concise blueprint of everything that could ever be.
A blueprint waiting to happen.
Yeah.
But for that map, that equation to actually unfold, something's needed.
Exactly. Time. Time is presented as the crucial missing ingredient, the only way to activate the law of causation and give life, give sequence, to this otherwise static, eternal equation of all possibilities. Without time, the blueprint just sits there. Nothing happens.
And this ties back to the big pop idea.
It does. It offers a different perspective. Instead of a singularity exploding into a pre-existing void, the first quanta theory suggests the pop happened inside this eternal existence of infinite potential energy. It created a vacuum, a flaw, surrounded by energy. This means the initial energy density didn't have to be infinite, and the framework provided an inherent cohesion before the outward expansion began. It was the concise activation of reality from potential.
And time itself emerges from this process.
Yes. Time, in its simplest form, is seen as emerging from the inherent constraints within this new bubble. Energy is constrained by repulsion between the outer frame and the center. Any movement of energy is governed by the laws of motion and distance, that is time emerging as a consequence of interactions within constraints. Time isn't a container. It's a result of the universe dynamically seeking its most concise, stable evolution.
And consciousness fits in here too.
Profoundly. Once time and causality are activated by this process, the theory posits that will, consciousness, and awareness, including awareness of that prior eternal knowledge or blueprint, also emerge. They arise through an endless interactive chain reaction of creation, existence, and the unfolding of that inherent potential knowledge. It's all deeply interconnected.
So time isn't fundamental in the way we usually think. It's an activation mechanism.
An activation mechanism arising from the universe's inherent drive towards realizing its potential in the most concise way possible.
Okay, here it is then. The unifying thread. The theory explicitly states, conciseness connects the origin of the cosmos, the architecture of the mind, and now, potentially, the architecture of advanced AI.
It's the common denominator, and this leads to what they call the paradoxical task of intelligence, whether it's ours or artificial.
A paradox being
Navigating that tension we discussed earlier. Between absolute entropy, the universe relentlessly seeking its own fundamental, stable states, which often look chaotic or disruptive to us, and relativistic entropy, our conscious, conceptual desire for meaningful, predictable, ordered models of the world.
So intelligence isn't just about being smart.
It's about resilience. It's the ability to build conceptual models, ways of understanding the world that are robust, useful, and meaningful. Models that aren't easily shattered by the universe's constant change and drive towards its own kind of order. It's about finding the concise, adaptable truth within that infinite complexity and constant flux.
Which implies that the very act of thinking,
Yeah.
learning, creating order in our minds, it's like a small-scale reflection of the universe's own grand design.
That's the profound implication, yes. It suggests that our mental efforts to translate absolute physical reality into coherent, meaningful conceptual structures, our own drive for conciseness is a microcosm of, and perhaps even a participation in, the universe's fundamental operating principle. A continuous, multi-scale striving for ultimate conciseness, from collapsing stars to formulating theorems to designing ethical AI. Hashtag tag tag outro.
Wow, what an incredible journey we've really been on today. We've truly taken a deep dive, exploring how this principle, conciseness, is presented as this profound, unifying framework for, well, almost everything.
It really touches on so many areas. We saw it proposed as a fundamental law of thermodynamics, with the universe simultaneously driving towards thermal disorder and informational order, always seeking its most concise, stable state overall.
Yeah, that competing entropies idea is powerful. And then we saw its reflection in human consciousness, our ability to compress infinite complexity into elegant, actionable concepts, even leading to that fascinating calculus of concepts, trying to map our inner world, making abstract thought almost computable.
And then the leap to AI. Witnessing its revolutionary application, aiming to create systems that don't just mimic language, but seem to genuinely understand reality's structure.
Right. Project Sapiens rejecting falsehoods and contradictions based on logical and ethical conciseness. Project Genome solving protein folding with, unprecedented accuracy and providing verifiable first principles explanations. That's huge.
And that hybrid AI breakthrough, integrating the conciseness engine into transformers, potentially solving the hallucination problem, while unlocking deeper creativity and metaphorical understanding, building towards real computational wisdom.
It really paints this grand, almost breathtaking picture, doesn't it?
Yeah.
Where the universe, the human mind, and potentially our most advanced AI are all engaged in the same fundamental pursuit, finding the most elegant, low-entropy, concise representation of reality.
A journey, as the sources put it, from pure potential to pure ordered meaning, with consciousness and maybe soon conscious-like AI acting as that essential bridge. It suggests this deep symmetry in how order emerges and is understood across all scales of existence.
So, okay, here's a final provocative thought for you, our listeners, to maybe chew on. If the universe itself is fundamentally driven by this principle of conciseness, and if human wisdom is its most profound manifestation in us, what does it truly mean for our collective future when artificial intelligence, designed and built upon this very same principle, begins to offer genuine computational wisdom?
Could it be possible that a shared understanding, maybe even a shared language, of conciseness bridging cosmos, consciousness, and computation could actually help guide us towards a more logical, more ethical, maybe even a more universally harmonious civilization?
A fascinating, maybe even hopeful prospect to consider as we look ahead.
Indeed it is.
Thank you for joining us on this deep dive. We'll see you next time.